today. Let me screen share first. So we're going to be using CodeQuest Academy for what for our competitive teaching session today. So it's going to be so CodeQuest was originally developed by Lockheed Martin, as just shown in the previous picture here, which is a very big aerospace company. So they develop things like uh, airplanes, and a lot of actually like fighter jets are developed are actually made by Lockheed Martin. So they basically made this whole program and this website for us to try coding on. Then we're gonna basically learn how to do competitive coding. So the link is, I believe you guys don't have the link yet. It will be in the Q&A chat. So if you follow into that link, give you guys a quick 10 seconds here. And if you hit the login bar at the top right here, hit login. And then so I already have my account created, but for you guys, you can go to create new account and then input your details, check your privacy policy, and then you guys should all have been created account. So you guys can write your names, your email, set your password, and then yep, you guys can create your accounts. I'll be logging in with my account. I'll give you guys a couple 1-2 minutes here. You can just write done if you're done in the Q&A chat, just to get the speed of how you guys are following along. I'll give you guys about 30 more seconds here. Uh, all right. So if you guys are on this screen or done with creating accounts, you will see your welcome and then your name here. If you hover over that spot, there's a tab called My Classes. Actually, let me zoom in. Oops. Let me zoom in here. So there would be, okay, not what I wanted. So there will be My Classes here. And then you can hit join class here. Then join the class that I'm gonna send you guys right now in Q&A chat. So input that code here. It's 16K 88B 63K. Then you'll get to Future of Tanzania, and then you can hit join class here. Students enroll currently two. I'll wait for you guys to join here. The code is in the Q&A chat. Are you guys there? So So just to show you guys again, go to your CodeQuest Academy, log in, and then up here, if you hover over your name, you'll see My Classes. You can hit Join Class, copy paste the link that I sent in the Q&A chat. Then you can hit Find Class and join the class. All right, 19, no, wrong one. 3 students enrolled, one more. Three students will be waiting a bit more. This step till now is mandatory steps, so I'd highly recommend joining the class. One more student enrolled. All right. Four students enrolled. If you start over from the beginning, so you hit students here, if you haven't created an account yet, you hit new account, enter your personal details, and then create account, and then you can hit create account. I'll log in separately, and then if you go hover over your name here, you'll see my classes. Click that, hit join class, and then you can use the code uh, class join token to join the class. I'll take the join class as an indication of that you guys are ready for the next step. Right, focusing on getting yourself enrolled before doing much else. We gotta get through class today. Alright, good job, Jesse. Alright, good job, Alicia. 5 years in a row. Good, good. Also, CodeQuest Academy logs you out quite often, so you might have to log in quite often as well. Keep that in mind. Slightly buggy. Good job, Alicia, Jesse, and Shadrach. I'm waiting for a few more people here. One more student enrolled. Good job, Gibson. Right. So I'll get the class going again now. You can still follow this without necessarily joining the class yet. So I will continue on with what we have to do for today. So first we're gonna solve. Oh, let me explain how this dashboard is laid out in CodeQuest. So if you hit dashboard on from your name, you'll see something like this. The number of problems solved, number of problems attempted, problems incorrect, problems not solved, total points, achievement earned. So you mostly have to focus on problem not attempted. And then in here today, we'll be solving multiple questions as our mentors go through. So the first one we're going to be doing is hello world. It should be right here at the beginning, or you can search hello world. I already solved this question, so I don't have it here. Uh, it's called hello world. You guys can search it on problems not attempted, click search, or you can just find hello world here, but it's easier if you just hit search and then find hello world. I can actually give you guys the link. It will be in Q&A section. You can also just click that link. So this is how it's laid out. Difficulty level, practice, meaning this is a practice problem. Points, it's worth 5 points. Status, I have already solved this, so it says solved, but you guys will say it's uh, unsolved or something. And then this is a basic description of the problem. And then download description, this gives you the in-depth description. Download sample IO, I'll explain what this does a bit later. And then submit your solution is where you actually submit your answers. So if I do download description here. Hello world, a practice problem. So welcome to Lockheed Martin CodeQuest Academy, blah, blah, blah. The important thing is, so there's a couple of things you need to keep in mind when creating this. So problem description. So this problem is unique in a way that there's not really anything that you have to solve. It's just getting used to how competitive coding is done. So to do how to do basic input and outputs. So I'll be using Replit here, but you guys can use VS Code or Replit. Both works pretty fine. So, all right. So first of all, if there's a couple things that you need to begin off with when you're doing competitive coding. The first line should I'll also explain how to do this in VS Code in a second here. So import SIS is probably going to be our most basic one. So in competitive coding, there's two ways to take in inputs. So we already learned how n equals int input. We already know this method. If we do, and then if let's do print n. If you do this, input 5, it will print 5. Very simple. There's a because there's a time limit to how long your code can be. The time limit here is not there's two kind of time limits in competitive coding. One is how much time you're given. So you're probably given around an hour or so to solve each question. But then the second time limit is how long your code can run. So if you have too many for loops or if you have too many while loops and the code takes way too long, you can actually get disqualified or the answer will be considered incorrect. So a faster way to do this is using import SYS, standing for system, and then you can do this. Let's do A equals SYS dot std in dot read line dot read line. And then you would also have to cast this into an int. So what this does, this piece of line does the exact same thing that does the exact same thing as input. Why would you use such thing? The reason being it's just faster. It's slightly faster than taking an input, so it takes the computer less time to process. So it's more useful in competitive coding, and that's why it's used. You could also usually at the end of this line, you would add, if you look at here, usually add r strip dot r strip. So what the r so this piece of code returns gives you back a string variable. The whole line of a file or whatever input you're doing, it returns it as a string. R strip, if you remember from our long back, let me move it there. So if you look at from our long back Python string method, there's R strip here. What it does is it removes any white space at the end of the string. So if your string has a bunch of spaces in the end, or your file is incorrect and there's a bunch of spaces in the end, it gets rid of that automatically so that it can be more efficient and it can run without errors. So usually this is the default. Oh, well, no, this is the default for receiving an input in a tournament setting for Python. You can use input, but this is faster. This is faster. That's about it. This is just faster. So if you do print A, it will do just about the same thing. So if you do 5, 4, it did 5, 4. This is the basic input formation of such things. You can also, and then later, if you so usually the first line is how many times you're going to iterate the code through. So we'll for now we'll just do for I in range n, or let's do a. We'll do print hello world. Spell that world. And then if we get rid of this, run the code now, and also get rid of this one. If we run the code now, if we do it 5, it'll print hello world 5 times. So this is how you do it. So in Replit, once you're done making your file, you hit the 3 dots here. Actually, no, you hit the 3 dots on the main.py. So if you look at here, there's main.py here. You hit 3 dots here, download, and then it will save to your computer. So I'll save it as hello world. And you can hit save. That will save it to your computer. You can see it's saved now. And if you go back to CodeQuest, you can hit backwards. It goes back. And then you can now submit your solution. So if you hit submit your solution, you can select your file. Mine's in the downloads and yours is likely also going to be in the downloads folder. So you hit downloads, you find the file that you just named or you just downloaded, click it, open, and then hit upload solution. So my status is it was a wrong answer. So this is what you get when your answer is a wrong answer. And so there's many reasons why there might be a wrong answer. I'll explain this a bit better a bit later. So for this particular question, what you have to do is there's a specific line that you have to do. So this is what they want you to do for the first one. So if you see here, let's code this from the beginning again. So you don't need these two. We'll just start from the beginning. We'll do cases. So this is the number of cases. So we're naming it cases here. Cases equals int sys.stdin.readline.rstrip rstrip. And then we're going to run it for the case num amount of times. Num in range cases that we just set. And then for cases, we're going to do print sys.stdin.readline.rstrip. So what does this thing do exactly? So this line of code basically takes an input and then prints it directly right out of the gate. So this returns a string, remember? And the return string is printed out directly without having to go through a variable, without having it set to a variable. It just goes through directly. So if we try this again, hit download, then we'll name it Hello World 2, save, and then submit your solution, file, Hello World 2, open, and upload your solution. This should give us, so it says judging in progress. If it stays, it usually takes around 10-20 seconds. And then once it's done, you can hit reload, and then it will do solved. So once it says solved, you have correctly answered the question and you're all set. So now we have just solved one question. Let's move on to the second one. So you guys can go back to problems not solved by hitting backwards twice. Problems not solved. And then you can search. The next one we're going to solve today is not so self-driving. So not so self-driving. I obviously cannot search it because I already solved the problem myself. So I'll send you guys a link in live Q&A section as well. So this is the next problem that we're going to be solving today. So hit download description. This will give you what the description is. Right. So not so self-driving. Blah 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 blah. The most important thing is they're creating a self-driving car with few sensors and a bunch of if statements. So Dwayne, okay, I'll read the whole thing. Dwayne and Johnson are your partners in a group project for your autonomous vehicle engineering course. However, none of you were paying attention in class. So you'll forget about the project until the night before it's due, knowing there will be no time to train a decent self-driving algorithm in just the night. You, Dwayne, and Johnson all decide to fake a self-driving car with a few sensors and a bunch of if statements. So problem description. Your task is to create an obstacles avoidance system that will output instruction based on information about obstacles and your car speed. So problem description and sample input, sample output is where you should really be focusing on what you're doing. So problem description, your task is to create an obstacle, blah, blah, blah. Sample input. The first line of your program's input received from the standard input channel. So standard input channel just basically means normal inputs. So you can either use the input method or you can use the SYS. You can use the SYS stdin.readline, which is what we recommend. Will contain a positive integer representing the number of test cases. So this is the first line of the test case. So first line will include the positive integer representing the number of test cases. So if it says 5 here, and we have 5 lines of test cases, how many input are we going to take? We're taking 5 in this case. And each test case will include a single line containing 2 numbers separated by a colon. So we can see that one first float colon here, and then second number. Let me zoom in a little bit more. First number colon second number, and then we have that 5 times because there's 5 test cases. Each test case will include a single line containing 2 numbers separated by a colon. The first line, a decimal value v, is between 0 and 200, like it says, and it is denoting the vehicle's current speed, or basically how fast it's traveling at. Secondly, the decimal value x, between 1 and 400 inclusive. Guys, you guys have to remember that it's inclusive and exclusive. It will come out a lot during your coding, but should just keep that in mind. Denoting the obstacles distance from the front of the car in meters. Those values will be rounded to 2 decimal places. So it will always be 2 decimal places. Even 0.0, even 0 will be included as 0.00 because it's 2 decimal places. Sample output. For each test case, your program must print instructions to the car based on the following criteria. So how should you do it? If the car is projected to collide with the obstacles in 1 second or less, it should swerve, meaning get out the way. Otherwise, if the car is projected to collide with the obstacle in 5 seconds or less, at the current speed, your program should output brake. And otherwise, your program should output safe. So, what this means exactly? So first of all, we gotta know how do we get the time to collide, projected to collide with the obstacles in 1 second or less? How do we know? How do you know it's 1 second or less? So using some physics knowledge, we can determine that. Going back to here. So speed equals distance divided by time. So from this question, we know the speed and the distance. That means to get time equals distance divided by speed, which means using the values given here, which were v for this current speed and x for the distance. So we can just do x divided by v, and that would be how we solve this question. So if it's less than 1 second, it should swerve. If it's between 1 and 5 seconds, it should say brake. And anything over 5, it should say safe. Now let's code this into an actual problem. So we'll keep this here. then we'll first start with our input statements because we're using the import sys.std method. We're going to do import sys, and then we're going to first take in the where is it? The first program's input received the standard input channel will contain a positive integer representing the number of test cases. So this number we will take in it first. So usually you would name this like capital N for number. So the number of time it's going to repeat through the test cases. So you state N equals int because we're taking this sys.stdin dot readline dot r strip. Remember, we have to cast it into as int because this thing, same as an input command, takes in a string and returns a string. And then we'll start writing our code. For I in range n. Now we are able to do the test cases 5 times. So now let's narrow it down to one test case. Let's look at this one. How do we do this one? So here we take in the number of test cases. Then here, repeat and run of times. So first, we have to take in the input v and x. They're separated. The v is the first one, x is the second one. They're separated by a colon. So how do you do this? V x. Remember, you can set multiple variables in one argument. And then we would do in, and then we would do sys dot stdin dot readline dot r strip. Oops. And then finally dot split and then semicolon and then colon. So what does this code do? Let's first look at what we're doing here. So we're setting v and x to a certain value given here. We want v to be 23.15 and we want x to be 98.34. So we set v and x in order here. So we take in an input here as a string. And then the dot split command, which we learned before, dot split, yep. It splits a string. Normally it splits a string by the spaces. So if there's a space, it splits it into a list that you can set it to individual variables. But this also has a parameter called separator. It is optional, but if you set the separator, basically meaning it will separate based on it will separate it into individual list item whenever that particular separator comes up. Normally that's a space. So if you look at here, it's split by welcome, there's a space, so it got split to split the split jungle. In our case, because we manually set it to this one, if we print v and print x right now, let's run this code. So let's do it just 2 times, 6 and 20, and then 3 and 40. So we can see that it got split. V is now 6, x is 20. Because it is splitting by the colon here. And then the colon is given here. Each test case will include a single line containing 2 numbers separated by a colon. So since it will always be separated by a colon, we can use colon to split such code. But both, if you also look at here, print type V. I believe this is the correct way to do it. 1, 5, 4. It's class str. We haven't turned it into a float yet, so we have to turn that into a float manually. V equals float, V, and then X equals float, X. So this line of code will be taking in so this is what we're doing now. So once you have this one ready, we can next move on to V, and we can next move on to what the wants us to do. Okay, my internet seems to be weird. Okay, it's back. So what the question wants to do, let's go back here. If the car is projected to collide with the obstacles in 1 second or less, at the current speed, your program should output swerve. Let's do this. So we already determined that the time is distance divided by speed. So if we do distance divided by speed, which is x divided by v, we can get some values here. To shorten the code, we'll set this as another variable, result. Yeah, right. Actually, yeah, we will set it as time equals x divided by v, and then we'll move on from here. So if time is shorter, if the shorter for 1 second or less, so it's shorter or less, it's inclusive. So smaller or equal to 1, you would print, it says print, you should output swerve. So we can print swerve. Simple. And then next, otherwise, so this would be a elif usually. Car is projected to collide with an obstacle in 5 seconds or less. So it should print out break. So if time, no, not if, elif time is smaller than 5, we should print break. There, we got it. And finally, otherwise your program should output safe. Can do else, print safe. And then we're done for the code. There is an error, so we will for now just try running this code as is. So let's look at the test case first. There's 523.15. So we'll first copy this over here as an input. So we'll copy this, so that we'll take that as an input. So if we run the code, we can do first hit 5, because we can see the inputs here. 23.1515, 98.34, 2.40, and 17.33, 6.79, 5.11, 0.00, 1.53. We got an error. So there is a problem here. So if you look carefully here, V is 0. It means the car's not moving. Logically speaking, if the car is not moving, we're never going to hit that wall. So a human brain would think, oh, it's just never going to hit that wall. But the computer does not know that. So we have to set it manually so that if the car is not moving, we can just say it's safe because it's never going to hit the wall. So to avoid the error happening here, so remember, trace back to the file line 29. 29 is time x divided by v. So to avoid that error from happening, to avoid it from getting divided by 0, we would do if v equals 0, we would just print safe. And then we would turn this into another elif. Oh, this is where I hit a second problem. So because if an elif is separated by a statement here, so we would probably have to do with getting rid of time and then just putting x divided by v here. So get rid of this one. And then now if elif else are in the correct order, and they should print out pretty well. So let's run that test case, just one of the test cases again, the one that gives us an error, 0.00 and 1.53. Safe. So I think it will work. So for this one, we'll just submit the solution as it, and then on the next question, I'll also go over another factor that you have to think about when you're making codes like this. So let's hit download. We'll name it. Its full name is not so self-driving. Too long. Uh, self-driving. There we go. Submit your solution. Select file. Self-driving.py. Remember, Python files are named .py. Open. Update solution. And then it should give you judging in progress. Solved. So that would be the answer to the second question. Oh, Alicia actually pointed out a pretty important fact here. So we could have technically avoided this. So normally an input, if we go back to the description here, they actually give us a range between 0 and 200 inclusive and 1 and 400 inclusive. So usually, because this is what's given by the program, you don't have to code this in. This will always be the case. So we don't have to limit v to between 0 and 200 because it will always be between 0 and 200. Or the problem is just wrong in general. Where this comes useful is letting you know how long your code is going to take, but you're going to learn this, but that is a pretty advanced topic. We're not going to be covering that today. I don't think so. So next, we're going to go back to ourselves, and then we're going to now try problem not attempted. The name of this program would be Addiply, ADDIPLY, ADDIPLY. I already solved this one, so no match found. Alicia, if you have more questions about that, you can ask away. Either me or one of our other mentors will answer it for you. So we have problem 44, Addiply. How do we do this? Problem background. Nowadays, if you put two things together, you need to come up with a cool name to describe the two things together, like Benifer and Brangelina. I have no clue what those are. In this problem, you will deal with a concept of addition and multiplication. You will Addiply. Your task is to write a program which does simple addition and multiplication based on two input numbers. The first line of your code is program's input. And the second one is, so first line is received from the standard input channel, will contain a positive integer, the number of test cases. So same as before, the first number is how much repeat you're going to go through the code. And each test case will include a single line containing two positive integers separated by a space. Separated by a space, remember that. The number will be small enough that they will not exceed the maximum integer size of when multiplied together. So Python technically has a limit to how large your number can go. It will never reach that. The problem is telling us that the autograder, which is what grades our program, which is what gave us these solved before, it will never make it error itself out at least. So sample output, for each test case, your program should output two numbers. The first one is the addition. So 2 plus 2 is 4. Second one is the multiplication. 2 times 2 is 4. Better example. So secondly, 5 plus 4 is 9. So we got the addition part down. And then 5 times 4 is 20. So we got multiplying part down. Separate these two numbers with a single space. So let's do this. So first, we'll do import SYS because we're using the faster way of input. N equals int sys.stdin.readline. Oops. And then for I in range n. We can do a. So we'll name the numbers a and b equals. So our code actually shows us a map command. I will not go over this not yet because I think it's a bit too complicated. So we'll just do the sys.stdin.readline. Oh, we forgot to do rstrip. .rstrip. .rstrip. And then we'll do dot split to get correct A and B, and then we'll convert A and B because they're strings to integers because we're doing with numbers here. So A equals int A, B equals int B. So we've got two numbers here, A and B. We can do, so the simple way to solve this problem would be just to do A plus, so print A plus B, and then print A multiplied by B. Actually, no, this would give you a wrong answer again. So we can do print A plus B, comma, A multiplied by B. So the reason why we do it this way is because one, these are both integers, so we can just play around like this. And the comma in between them basically adds a space when you're outputting it, gives you a space between it. So if you run this code, I added too much. Run this code. We can do two test cases, let's say 5 and 7, 4 and 9. That gave us so if we go back to using the original one, so it's 3, 2, 2, 5, 4, 3, 8. We'll just copy it over here. So the 3, I gotta comment these out so they don't affect the problem. 3, 2, 2, 5, 4, 3, 8. So we can see 2 times 2, 2 plus 2 is 4, 2 times 2 is 4, 5 plus 4 is 9, 5 times 4 is 20, 3 plus 8 is 11, 3 times 8 is 24. That's how this code is run. So it seems to be doing fine. So this question, we can just go as is. Simple enough, simple question. We'll hit download. Then we'll name it add apply because that was the name of our question. Go to here, go backwards, submit your solution, Select add apply.py, upload solution, judging in progress. And if you reload the tab, and we got solved. So we got the correct answer. So next question, we'll go over two more topics. So next question we're going to be solving is you guys can search A, E, I, O, U, the vowels, and then I'll also send them in the Q&A chat. And with this question, so let's read through what we're trying to solve here. So the English alphabet contains 5 vowels, A, E, I, O, U. The 21 are called consonants. Vowels are like glued to the English language, and without them, word would be unpronounceable, so they're very important. They're together most common letters in the English language, so those are most commonly used. So we need to count how many vowels appear in a series of sentences. So let's look at the sample input here. The first line of your program's input received from the standard input channel, positive integer, representing the number of test cases. So look, again, the first is the number of test cases. So majority of the problems, the first number would be the amount of test cases. So, and then a single line, and then each test case is a single line with a series of lowercase. Remember, it's lowercase, where it's separated by spaces. For each test case, your program should print out the number of vowels contained in the input. So this one has O, E, U, E, I, U. O, E, U, E, E, I, U. There's 6. Second one has O, O, U, O, A, I, O, and A. So in the total, it has 8. Uh, total has 8. And the last one has 13. If you count all of them, it becomes a 13. So let's see how we're going to tackle this problem. So what most likely we're going to do is we're going to obviously loop the test case over multiple times. And then we'll just find for every so we're probably gonna loop over every single item in that string and then check if they're A, E, I, O, or U. We're gonna check for every substring here, C, O, D, E, every character. We're gonna check them if they're a vowel. So let's do this. A second here. We can do import SIS. And then we'll take in n equals, again, int sys.stdin.readline dot rstrip. Rstrip is not really necessary most of the time. It's just a safety measure to hopefully not meet a bad program per se. N equals into SIS, and then for I in range n. So we're gonna loop over it every time. We can do so we're in this case we're just taking a string. So we can name it str equals just sys.stdin.readline.rstrip. So that will read the line for us. So that will read each line, this line, and then next this line for us. And then if there's any trailing spaces, it'll get rid of it automatically for us. And we can do, so we're gonna loop through all characters in str. We can do if, no, of oops, for Uh, let's say for a character, we're gonna say cha in str if we're gonna check if character is a vowel. So if cha is in a e i o u. So remember, because the problem specified that it was a lowercase, we don't need to count in uppercase letters, so we just have to do it lowercase. And if cha is in a i o u, meaning it's one of them. Oh, we forgot to add a counter here. Okay, so we can do count equals 0 because there's currently 0. So if cha is in a e i o u, if it's a vowel, we can increase the count by 1. And you can do print count once that for loop is over. And then this will repeat it 3 times. So if we run this one, let's do only one test case first. Code quest is fun. Code quest is fun. 6, which is what we're expecting, 6. Now we're going to go over a topic that might look more complicated, and it is somewhat more complicated at start, but it's also better in many ways. So instead of doing this, what if we set the solution to a function itself and just loop with a function? I'll explain what this looks like. So we got n here. And once we get to the main part of code, we'll define. So we can comment this one, the whole thing out. And then we'll do define. We're gonna get the part of this solution in a separate function. So define, let's say in this case, we're gonna define a solution. And then the input is gonna be the string. So we're gonna name the input str. So str scope is under this I guess function. We can do the same thing for cha in str. We can do if cha in a i o u. We also have to add count here. Count plus count equals 0. Oops. And count plus equals 1. And then we can do return count or print count. Both works. I'll explain how they're different again. So we have our solution defined, but this itself doesn't do anything. It's just there. It's just waiting for it to be called. So we can call it by using for I in range n. We're going to first take in the str input, xys dot. So this doesn't have to be str. We'll just call it stri. Xys dot readline the r strip. And then we will do solution stri. And then we'll print this out. Oops. If we run this code, code quest is fun, give us the exact same answer. What gives? How do we do this? So how this basically works is you're so you're making the main part of solution, excluding the input, into a separate function. Why would you do this? This is so much simpler. This is so much more complicated. You have to make a whole separate one. So defining functions is very important once your code gets really, really long and it gets confusing to know what you're doing. And if you're using the same thing repeatedly, it's much easier to do this way. And it's also easier to debug your codes because instead of relying on changing things here and then doing everything here again, you can just comment this one out and just try running solution, and then do code whatever you want in here. Code plus this fun. We can run it like this. This fun. And we can print this one out separately. And then that would do. Oh yeah, we gotta input n first. So, and it doesn't matter because we are not doing anything. It gave us a 6. So making it into a separate function allows us to use the code wherever you want, making it much simpler for you to do it. So for simpler questions, using the method here is better. It's just writing it all in one for loop. But as your questions get more complicated, more difficult, and you need to actually debug your code, so check for bugs, this method is a much faster and better method. You can change this to a print count and then get rid of print here and just solution stri. That is up to you. That is how you prefer it, but this is the generally recommended version of how you code in CodeQuest and how in competitions in general. One last thing before we submit this code, what download sample IO does is if we download, so we'll download this into downloads, and then it will show you. Okay, I probably have to share the whole screen again. Let me do that real quick. This is the last one. Change windows, screen. It's a bit wide. So AI will write you examples, and it'll give you 2 files. One is as an out file, which meaning it gives you what it should be like printing out, and then one.in file. You can open it with a notepad app, simple, and like always. And we'll do this is the standard input. That's what the autograder is actually feeding the program. As an example, there's usually a lot more test cases than one. The autograder doesn't tell you how many there are, depending on what autograder you said also might, but this is basically an example of what the solution should look like, what the output should look like exactly, and what the input should look like. So that's what download sample IO. IO stands for in and out. So going back to our original question, going back to our original window here. We're going to download this one again. Go to, we're going to name it. I should probably share my whole screen for this process. So we're going to name it whatever we want to. In this case, the problem name was IEIOU. So we'll save it like that. We'll just submit your solution. Select AEIOU.py. Upload my solution. And in theory, we should get a correct answer. Solved. So that is how you used how you put it into a separate function that used sample IO and submit your solution. So we together solved around 4 questions today, and now that is it for me. I'll pass it on to our next person who will solve more questions with you guys. I think the next is Aiden. All right.
Yeah, so I guess I'll be doing this next part. Sorry, give me like 1 second. I need to really quickly do something. Um, also, again, sorry. I still don't have a camera, unfortunately. I should have one by the next time that we have a class, but just for today, I won't be able to have a camera. Um, so yeah, let me Um, Sorry. Okay. I'm gonna share my screen. Just give me 1 second. To do that. Where is it? Okay, there it is. Okay, is everybody able to see my screen? Okay, I'll just assume. Yeah. So I'm going to be going over 4 different problems, just like we did um, previous one. And the 4 that we're going to be going over are called Around the World, Autocorrect, Batter Up, or sorry, Around and Around, Autocorrect, Batter Up, and Bigger is Better. Um, so I'll just send. Um, I'll just send the problems in the chat, and then you guys can be able to see that. Um, okay. Oops, that's a bit too close. Okay. So the first thing that we'll do is around and around. And I just sent that in the chat. So for around and around, um, I'll just read through the thing. Um, or I guess I should probably show it on here, right? So, um, sorry, I don't think I'm logged in on Chrome. I think it logged me out earlier. So, sorry, this is a little annoying, but I think I got logged out of this. So, I guess it doesn't really matter. Okay, sorry about that. Um, okay. Um, so yeah, we'll look at around and around, and I guess we'll just download description. Okay. So I guess I'll just read through the problem background, problem description, like Benjamin was. So um, problem background. In 1962, John Glenn completed a historic space flight orbiting the Earth 3 times in a small spacecraft. This flight was one of the many that paved the way for an era of space exploration, eventually leading to the moon landings just 7 years later. Despite the seemingly simple nature of Glenn's flight, it still required very precise calculations to ensure that he remained in orbit and didn't either fly off into space or come crashing back to Earth. Objects in orbit don't remain in space simply because they've left the Earth's atmosphere. They're still constantly falling towards Earth. The reason they stay in space is because they're moving so fast that they continuously miss the Earth as they fall. In the case of John Glenn's historic flight, he was moving at an orbital speed of 17,544 miles per hour, or 28,234.8 kilometers per hour. This is fast enough to travel from New York to London in less than 12 minutes. During his entire flight, which lasted just short of 5 hours, Glenn traveled a total distance of 75,679.3 miles, or 121,794 kilometers. Your task today is to determine how far an object in orbit at a particular height will travel during a single orbit of Earth. Problem description. Your program will be given the altitude of an object orbiting around Earth at the equator. Using this information, your program must calculate the total distance traveled by that object during a single orbit. It will help you to know that the circumference of the Earth at the equator is 40,075 kilometers. Sample input. The first line of your program's input received from the standard input channel will contain a positive integer representing the number of test cases. Each test case will consist of a single line, including an integer representing the object's altitude above the Earth's sea level in kilometers. All altitudes will be greater than or equal to 160, the lowest possible orbital height for Earth. That's like some sample inputs. Sample output. For each test case, your program must output the distance traveled by an object orbiting around the equator at a given altitude in kilometers. Each value should be rounded to the nearest tenth of a kilometer, one decimal place. So, okay. Um, yeah, okay. So first I'll kind of try and go through like the thought process of how we would try and solve this problem. Um, so hold on. Okay. Um, so um, yeah, first thing that we need is to like get a bunch of inputs. So um, first thing that we'll do um, is just get the number. Sorry, get the number of get the number of inputs we want, and then we want to. I mean, there's a few ways to do this, but one way you could do it is to put all of them into a list and then just iterate through that list. That's the way that I'm doing it. So we're just going to um, store in a list and iterate. And then from there, um, the way that we're going to be doing this, we're going to be assuming that Earth is just completely like stable or like it's not like orbiting because I'm guessing just like um because how fast we're able to like go around the Earth, it barely orbits at all anyways. So we're just going to assume that it's staying still. Um and um right, how do I explain this? Like if you the way that we're going to calculate our numbers um, is by using this specific value here. We know that the circumference of the Earth at the equator is 40,075 kilometers. If you remember, um, the circumference of a circle is, or assuming that Earth is a perfect circle in this scenario, um, the circumference of a circle is equal to 2 pi r. So um, what we're going to want to do is basically add this number to whatever radius we get with this circumference. Because if we get the radius from this circumference, we'll know what the radius of the Earth is, and then by adding this, that's where our altitude is. We can find our new circumference, and that would end up being um, the 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 total circumference that we encircled. So basically, we'll first divide by 2 pi, and then we'll add the altitude, and then we're going to multiply by 2 pi again. And then that should end up giving us our answer. Um, so yeah, let's just get to coding, I guess. So first, we'll get the number of inputs that we want. Of course, like Benjamin was talking about, we're not going to be using um, we're not going to be using the input. We're going to be using s like sys dot stand in whatever stuff. So first, let's import sys, and then let's just use n. Do sys dot and just I guess put in the thing, and then the R strip at the end to get rid of any unwanted white space. That's nice, but and then after that, um, or actually, I guess we should make this equal to altitude because, or actually, no, we have to make this equal to n because we're getting the number of inputs. Um, so now we want to store them in a list and we want to iterate through each of them and then do all of this code inside of our for loop. So um, we're going to do for I in range n. We're going to um, yeah, we're going to need some other inputs from or I guess actually this should technically be in, above, but we're going to get some more inputs. So um, I guess let's create a list outside altitudes, and then just make that equals nothing for now, and then just create a temporary variable, and then get and then do this again. Um, and then we're going to want to throw that inside of oh sorry, this has to be an integer. That's I forgot to do that. So yeah, we're just basically going to throw this into the list so we can just do altitudes dot append temp, and that'll every time that we put in a new input, we're just going to put it at the end of altitudes. So now we're going to iterate through altitudes. So for I in altitudes, um, and then basically just do our code in here, do our code over here. So first thing we're going to do, actually we can put this out here because this is something that we only want to do once. Because if you remember, we want to lessen the amount of time possible, make it like the fastest code we can. So we're only going to divide by 2 pi once. So um, of course our okay, let's just call it radius because we're getting the radius of Earth using this. And of course the circumference is 40,075. Um, and then we have to divide by 2 pi. Um, and I think we went over this at some point, like a few weeks ago, but there is a way to get pi into our code, and that's by importing math and using math.pi. Of course, you could just like write out pi to a certain digit, and at some point, it's not really going to matter how many digits you write. But just to get the most accurate results, we're going to use it. We're going to import math and use math.pi. Um, so we're going to divide by the quantity 2 times math.pi. And this is going to end up giving us the radius of Earth. Um, and now we're going to, at the altitude, multiply by 2 pi. So let's add the altitude first. I'll put that in here. Um, so radius plus equals um, or yeah, radius plus equals uh, I, because that's the specific altitude that we want inside of this specific iteration. And then afterwards, we're going to want to multiply by 2 pi again. So we can just go straight to a print statement, or I guess, yeah, we'll just yeah, we'll just multiply by 2 pi inside of this. So we're going to do radius. I guess okay, we're actually going to do something a little different. Um we're going to make temp another variable called temp radius, just so that we don't end up messing up our original radius value, and we'll just have that equal to radius at the start of each iteration. Um, so temp radius plus equals I, and then we're going to print our radius or temp radius, sorry. um, times the quantity 2 times math dot I. Um, and then if we were to run this now, um, we can use this sample data. So 3, 160, 200, 265. So 3, 160. What was the other ones? 200 and 265. 200, 265. Um, oh, sorry. This also has to be an int. So yeah, let's just try it again. 3, 160, 200, and 265. And we get our values. I did forget one thing, though. Sorry. We need to round our values because they do say that we want it to the nearest tenth. So if we have the nearest tenth, that means that we want to put it to, we want to round it to 1. If you guys remember the round function, we first have our value, and then we specify how far we want to round it after it, the second input. So this should give final thing, which is 3, 160, 200, 265. And yeah, we have our final things here. Okay. Yeah, I hope that made sense. So, yeah, that is around and around. Um, and I can't really submit it, but if you guys want to, then you guys are allowed to do that. Just submit it into the link I sent. Um, so yeah, and then while you guys are doing that, I'll move on to the next one. And the next one that we're going to go over um, is called uh, autocorrect. Sorry, yeah, autocorrect. So let's take a look at this. Um, I'll give like one more second to wait, and then I'll just give one more second and wait. Okay. And I guess we'll just move on to the next thing. So yeah, next problem, autocorrect. Problem background. Typos are an inevitable part of typing. Thankfully, most typos happen for the same reason. A user presses one key when they mean to press a different one. Fortunately, most autocorrect algorithms are excellent at identifying when this sort of typo happens. One approach they can use for this is measuring the Hamming distance between what you typed and a word in the dictionary. Problem description. The Hamming distance between two strings of text is the number of character substitutions that need to be made to change one string to the other. For example, the words apple and appler have a Hamming distance of 1. They are identical except for the last letter. The words computer and computer have a Hamming distance of 3 due to the 3 character differences K to C, T and D, and E to I, respectively. Lockheed Martin is working on implementing a new autocorrect feature for their internal communication tools. You will be given a dictionary of correctly spelled words, followed by a list of potentially misspelled words that need correction. For each of these misspelled words, your program will need to identify the dictionary word of the same length that has the smallest Hamming distance to the misspelled word. Ties will not occur, and words will not change length as a result of their misspelling. Um, Sample input. The first line of your program's input, received from the standard input channel, will contain a positive integer representing the number of test cases. Each test case will include a line with two positive integers separated by spaces, D, the number of dictionary words, W, the number of misspelled words. Um, D, lines containing a string of lowercase letters representing a correctly spelled dictionary word, and W lines containing a string of lowercase letters representing a potentially misspelled type word. Um, so yeah, this would be an example of some um, of like a form of uh, like this. And sample output for each test case, your program must print the dictionary word that has the shortest hamming distance to each of the misspelled words. Each word should be printed on a separate line. So, for example, given this input, uh, computer, um, this K is wrong, this D is wrong, and this N is wrong. Um, so if we had like, well, okay, here for computer, mouse, and program, you'll notice that all three of them are have a different amount of letters. So in this case, it would be pretty simple to do to say that this it has 8 letters, therefore it has to be a type of computer. And like house that has 5 letters, it has to be a type of mouse. But that's not that's not always going to be the case when we're giving inputs. That's just what our sample input is giving. Um, so there could be, uh, or I think there's allowed to be inputs where you have the same amount of letters. Um, but yeah. So for example, this one is obviously a type of computer, so it's going to print out computer. And it does the same for house. It goes to mouse. Compu goes to computer. Anagram is similar to program. And then this random string of letters. I mean, if you look at a keyboard, the random string of letters is actually each letter is actually really closely placed to another letter in the word program. So that's also going to give program. Um, so yeah, let's just do this one. Um, I think I can take this out now, right? Um, okay, I'll just take it out. Okay, so let's try to think about what the ways that we can the way that we can do this one. So first thing that we'll do is of course do the same thing as usual. Get the number of inputs and um, put the inputs in a list. Oops, I misspelled a lot. Number input and put the inputs in a list. Okay. And then after we have our input. Um, I mean, this one has like each input is going to have this plus a bunch of these. So um, it's basically going to be a list made up of a bunch of lists. So next for and now I'm just going to go for like through each specific like input that we're given. Um, we want to like get the number of dictionary terms. Going to call them dict terms and typo terms. I'm going to call them typo terms. Um, and I think the best way to do this one is to just put them in a list as well. So I'm just going to write to put them in a list. And then now we have uh, a list of our dictionary terms and a list of our typo terms. So from there, we can um, we're going to iterate through each of the typo terms, and in each iteration of the typo terms, we're going to iterate through the dictionary terms because we're trying to check the Hamming distance um, between each dictionary term from each typo term. So um, iterate through typo terms, and then iterate through dictionary terms. And we're basically going to try to find the Hamming distance um, by comparing each letter to the dictionary term that we're comparing it. So, like, for example, if we look at computer and computer, these two, um, we're basically going to check in K with C, O with O, N with M, and so on. So we're actually going to have to iterate through every single letter, um, iterate through each letter of our typo term. Um, and then we just need to find the Hamming distance. Um, so find the I'm just gonna call it ham distance of between each dictionary term, and then find the minimum one, and then just print out whatever dictionary term has the lowest Hamming distance. So print the um, print the word with the lowest Hamming or yeah ham distance dict word. Okay, so um, now we have our like I guess like what we want to do. So now we'll just code each thing. So again, we're going to import this and then just use that to get all of our inputs. And it's equal to, and I'll just write it. I'll try it out. Okay, and then mm, okay, so we've gone through each of our ends. So um, yeah, for every time that we do this, we're going to um, do all of this. So get the number of terms and typo terms, put them into a list. So we're going to have another input for our 3 5 here. Um, and I'll just call this like nums because we can't make it same as n. Um, and then we need to put them into well, we need to first parse 3 and 5. Um, so the way that I'm going to do that is just um, okay. This might seem a little weird, but I'll explain it in a second. Um, okay, so what I'm essentially doing here is so I'm putting I'm basically turning our num into a list because when we're dealing with a number and the space and another number, it's really hard to sort of parse that, or at least for the code to parse that. So instead, what we do is we just put them into a list, and it's going to end up in a sort of so like in this case, it's going to end up as three space five. And actually, I shouldn't be putting this as two. This should be -1 because there could be any amount of spaces in between. Um, and this is basically getting the first one, which is always going to be our first value, and then this always going to end up being the last one, which is going to be five in this case. Um, and by putting them in a list, it ends up being something like I said, three space five. So the first one's three, the last one's five. So now we have our dict terms and our typo terms, um, like pretty like now we have those basically. Um, so now we're going to be iterating through number of dict terms and typo terms to basically get a list of those. So for I in range of this, oops, we're going to be reading numbers in again. And then I'll call these, actually, this has to be a temp variable because we're just appending it to a different list. So let's just, I think we should make them in here because we are iterating over here. So it's better to just clean them out before we start again. The dict terms and then typo terms. Um, I think these need to be integers. Okay. So yeah, we're getting our value in, and then we're just appending it to the end of dict terms. Or yeah, dict terms dot append temp1, and then we're going to be doing the exact same thing but with typo terms. So now we have all our dict terms and typo terms inside of two different lists, dict terms and typo terms. Um, so now we're going to iterate through each typo term because we want to give a value basically for each. We want to print something every typo term. So for um, for I, or I guess not I, not no I works for I in typo term. Um, and then we're going to iterate through dict terms because we want to look through each specific one. So for J in dict terms, and then we're going to iterate through each letter as well to check for each specific letter. Um, I think um, we're K in I because we basically want to get through each letter. We're going to now find the ham distance between each dict term. And to do that, we're going to have a sort of counter. So over here, let's add a little thing. Let's call it ham dist. And let's make that equal to 0. Or actually, let's put that, I think we need to put that over here. Um, yeah, so for each thing, we're going to um, check if it's, or actually, sorry, I should do in range len of I. Because the way that we're going to do this is we're going to check if the value of I at k and the value of j at k are the same. So if I K is not equal to J K, we're basically going to be adding one to hamdist. So we're basically using hamdist kind of like a counter for the amount of wrong letters we have, because that's kind of what the ham distance is. Um, and we also need to check that that k, so that we don't have any errors with k going over the amount of numbers or the amount of values in the list. We also need a sort of check uh, to make sure we're not going over. So if k is less than um, the length of j, and then we need to put this in there. Um, so yeah, this helps us find the ham distance, and yeah, this should be basically all we need to get our ham distance um, for each specific thing. So now we're going to need to basically find the minimum ham distance between each of our three or in this specific input are three different dictionary terms. So to do that, we're going to create another thing. We're going to create a we're going to create a list. Let's just put it outside here, and this, let's just call it that, and that's a list. So at the end of every dictionary term, we're going to want to um, or sorry, not no, yeah, at the end of every dictionary term, we're going to want to append each the ham distance um, from each word. So hamdist dot append hamdist. Um, and then um, yeah, so then we want to print the dictionary word with the lowest ham distance. So first, let's find uh, our minimum value. So we can call, or actually, more specifically, we want to find the position at the place where we have um, at the place where we have our lowest ham distance. So um, we're going to use dot index, because if you remember, um, I don't remember where they put it specifically. Yeah, ties will not occur. So each value here is going to be different. So we're going to do post short for position is equal to ham uh, ham dis dot index of like the lowest, so the minimum of ham dis, and that's equal to the position that we want um, in our dictionary term to print. So now we're going to print um, dict term, and we're going to use position to now we're going to use position as our position. Uh, why is there a problem there? Is it this? It might be this. Mm, could be anything wrong here. Okay, I guess we can just test out our input, see what happens. So yeah, one. Oh, oh, this has to be an integer. Oh, I keep forgetting to put these as integer. That is my bad. These aren't integers, so that's fine. Okay. 35. computer, mouse, program, um, um, oh, wait, actually, we need to stop this. I completely forgot this. Should be dict terms, not dict term. What's that way around? Yeah. So, uh, okay, that's weird. What's the problem here? I know what I know the problem. This has to be over here. The reason why that has to be over there is because um, otherwise we're just gonna keep appending to ham this, and it's just going to go over the index that we want. Um, and we basically want to reset it every single typo term just to make sure that's clear. So do this again. Uh, Here. It's weird. That should not be happening. Okay. Here's an idea. We can try just putting this all on one line. Not this. Just instead of making creating a completely new variable, we try putting them on one thing. Um, should not be doing this. Oh, you know what? This should be inside here. That might be the problem. And yeah, that's okay. No, okay. I know how to solve this problem. There is a thing in here right before, um, where we can just check preemptively whether it has the same amount of um, letters as one of our dictionary terms. Um, I guess that not only makes it faster, but it also makes it more accurate because we're getting mouse there, since that technically has the least amount of um, the least amount of distance, because it has the least amount of words, since every single word is going to be wrong. So we can just preemptively check for the total amount of letters in each, um, by using an if statement. So if um, uh, len length of I is um, not equal to the length of j, Then we're going to want to just append, well, okay, more specifically, we want to append a number that's obviously not going to be um the shortest time distance. So we're just going to append the length of I plus one, and then we're going to continue because it's not really any use um, to do this for loop after if we don't if they're not the same length. And also that really just takes out the use of this if statement as well. So we can get rid of that as well. Okay, this should work hopefully. Okay, there you go. Computer, mouse, computer, program, program, which is what's shown here. Computer, mouse, computer, program, program. Um, I'll zoom out a tiny bit so I can show the whole thing, but yeah, this is the code we want for autocorrect. Um, okay. Yeah, I'll give you guys a bit of time to um, submit that. You guys want to? Okay. Um, so yeah, I've gone a bit over time. Sorry about that, but um, yeah, I think we'll just end it now. Um, and yeah, I'll just pass it on to whoever's giving the homework for today.
Yeah. So that is it for today, guys. Hopefully you are able to remember we went over. I know it was a lot of material today. So yeah, make sure if you guys have any questions, make sure the Q&A chat, and we will get back to you as soon as we can. Um, and yeah, we'll see you next week on day 14. Bye, guys.